What sets Riskion apart? There are a myriad of risk tools and processes to choose from. While Riskion is in alignment with majority of ANSI, ASEE, ISO open group standards, as well as a COSO framework, and the Department of Homeland Security's risk lexicon, it contains important capabilities that sets it apart from risk assessment management tools in existence today. In this video, we will briefly discuss what sets Riskion apart. Let's briefly look at some of Riskion's unique capabilities. Subsequent videos will illustrate these capabilities in more detail. Riskion includes a customizable wording template that provides a taxonomy that categorizes and organizes risk terminology, reduces the myriad of risk terms in use to just 7, and is customizable to fit any organization's risk vocabulary. This is important because it eliminates ambiguity and miscommunication from the misuse or different understanding of risk terms used in an organization. The Department of Homeland Security's risk lexicon contains 123 terms. Furthermore, different organizations use different words for the same terms having the same or similar meaning. We have determined that a coherent risk analysis can be described using 7 and only 7 terms. These include 4 elements and 3 measures. Default words, which can be tailored to any organization's needs, are shown here. 4 risk elements: events, sources, consequences, treatments, and 3 risk measures: likelihood, impact, and risk. Riskion includes tools for top-down and bottom-up collaborative risk identification, structuring, and evaluation with role-based participation. Results are based on the wisdom of crowds rather than the delusion of crowds. Treating risk probabilistically adds rigor, scrutiny, and structure to the risk analysis process and outcomes. The challenge is to produce comprehensive and meaningful measures for likelihoods, impacts, and risks. Other tools produce incomplete or mathematically meaningless results. Mathematically meaningless because they use assessment and measurement methods that are not ratio scale. For example, expressing the likelihood and or impact on a scale of 1 to 5. In order to derive mathematically meaningful risk measures, we need to produce ratio scale measures for events, likelihoods, and impacts. For likelihoods, although we sometimes have historical data or can perform simulations based on historical data, we must do more because there is no data about the future, and it cannot always be assumed that the future will look like the past. Riskion can incorporate subject matter expert judgments, as well as the wisdom of crowds that are necessary, especially for low likelihood events. For impacts, existing tools use monetary values for losses, or even try to regress to infer dollar values for qualitative losses, but do not consider the relative importance of the objectives, which is subjective. Riskion incorporates human judgment about the relative importance of objectives and the impact of risk events on those objectives. Riskion rises to the challenge of producing both comprehensive and meaningful measures for likelihoods, impacts, and risks. It is the only tool available that is both comprehensive and produces meaningful risk measures. Why? It is well known that adding or multiplying ordinal measures is mathematically meaningless, but existing tools do this anyway. A comprehensive risk analysis requires combining, multiplying, and adding measures from multiple sources, events, and objectives. Riskion is the only tool that has the structuring and measurement capabilities necessary to accomplish this. In order for a risk assessment tool to be comprehensive, it must measure and synthesize multiple sources, hazards, or causes of risk, each of which can lead to multiple events. It must also assess the impact of each of these events on multiple objectives. It must do this using both hard data, when available, as well as judgments from subject matter experts, high-level managers, and in some cases, the wisdom of crowds. Structuring risk in a hierarchy increases meaning by facilitating understanding and communication, as well as establishing the relationships needed to synthesize likelihoods over multiple sources and events. Structuring objectives in a hierarchy facilitates understanding as well as synthesizing the impacts of multiple events to multiple objectives. Riskion's measurement methods, some of which we will look at next, produce mathematically meaningful results consisting of ratio scale measures of the probability or likelihood of sources, ratio scale measures of the probability or likelihood of events given sources, ratio scale measures of the importance of objectives impacted by events, ratio scale measures of risks, and ratio scale measures of treatment effectiveness in reducing risks. For example, one of Riskion's numerous measurement methods that produce ratio scale measures is called pairwise comparisons with known likelihood. Here we have pairwise comparison of two factors. The likelihood of sources or events are determined by the relative eigenvalues derived by the eigenvector or computation of the reciprocal matrix of pairwise comparisons normalized to the likelihood of a source event with known likelihood. In this case, 40% for the event competitors with new and better technology. Another but similar Riskion measurement method is pairwise comparisons without a known event likelihood. If the events being considered are mutually exclusive and collectively exhausted, then the normalized priorities will represent estimates of the actual likelihoods. Otherwise, they'll represent relative likelihoods. While absolute likelihoods convey more information, relative likelihoods are adequate when comparing relative risks of events and when allocating resources to reduce risks. When data is available, as for example historical information or output of tools such as Monte Carlo simulations or fault trees, the data can be used directly or translated via utility curves or step functions. Ratings is another Riskion ratio scale measurement method. A rating scale consists of a set of rating intensities and associated ratio scale likelihoods. In addition to some predefined rating scales, as the one illustrated here, a unique rating scale can be developed for estimating the likelihoods of any specific source or event. The ratio scale likelihoods for the intensities can be based on logic, such as likelihoods computed from the occurrence rates using a Poisson probability distribution, or computed from pairwise comparisons of the likelihoods of the rating intensities, or copied from existing scales published in the literature or in use at an organization. Still, another Riskion measurement method is pairwise of probabilities. Here we see pairwise of probabilities for an event, competitors with new and better technology, given that there is a poor project plan. Based on the pairwise comparisons of the different probabilities, the likelihoods of the probabilities are derived as the principal right-hand eigenvector of the matrix of comparisons, and the likelihood derived as the weighted sum of these likelihoods, here about 39%. As we will see next, Riskion's bow tie diagrams with ratio scale priorities depicts the relationships between the 7 risk elements, the ratio scale measurements of the likelihoods, vulnerabilities, impacts, how the ratio scale measures are combined to produce a measure of risk, and how the risk can be reduced by applying treatments that can reduce the likelihood of threats, reduce vulnerability of risk events to threats, and mitigate impacts to the organization's objectives. This is a bow tie diagram for the risk event loss of funding. At the left are the sources or causes in the derived ratio scale likelihoods. Next are the vulnerabilities of a loss of funding event to each of the sources, designated as V. The product of the two is shown next, and the sum of these is the likelihood of the event. At the right, we see the objectives that this event impacts, their priorities, designated as P, and the impact or consequence of the event on each of the objectives designated as C. The product of consequence and priority are shown as C times P, and their sum is the impact of the loss of funding event. Finally, the risk of the loss of funding event, 2.88% in this example, is a product of its likelihood and its impact. A synthesis of the likelihoods of the events based on the likelihoods of hazards, threats, times the vulnerability of events to the hazards, and a synthesis of the impact of the events based on the impact of the events on objectives and the importance of the objectives results in a risk register of events as shown here. Such a register is mathematically meaningful only if the measures of likelihood and impact are ratio scale measures, as they are with Riskion. Unlike other risk tools, Riskion will not produce nonsensical mathematical results based on arithmetic functions on ordinal scale measures that are not logical, consistent, nor defensible. This example is typical of many or most risk analyses being performed prior to the introduction of Riskion. Both likelihood and consequence scales are ordinal measures, so it cannot be assumed that the interval between a 4 and a 5 has the same meaning as the interval between 3 and 4 or 1 and 2. Ratio scale measures of both likelihood and consequence are needed to compute the risk and produce a meaningful heat map. A Riskion heat map is based on ratio scale measures of likelihood and impact. The size of the bubbles here are proportional to the risks, which are the product of the ratio scale measures of likelihood and impact. With Riskion, treatments can be identified for reducing risks by reducing the likelihood of sources from occurring, preventative treatments, or by reducing the likelihood of events from happening given specific sources, again preventative, or by reducing the consequence of events if they occur, which are mitigating treatments. Here in the white boxes, we see treatments for reducing the likelihood of the sources, treatments for reducing the vulnerability of the loss of a funding event to these sources, and one treatment for reducing the impact to delay in starting the train service. The outcome of the Riskion risk assessment provides options to decision makers that are feasible, cost-effective, politically viable, and achievable from a technical and execution perspective. Actionable results in the form of optimally allocating resources to reduce risk are available to management throughout the organization.